Section 3.4 is on factoring trinomials using algebra tiles, and this is like a little bit of a lab. Algebra tiles can be used to help you understand factoring. It's kind of a visual aid, I suppose, to help you understand factoring. Algebra tiles are probably most useful when you're talking about all positive terms. It can be a little bit tricky when you're talking about negative terms, and there are some types of factoring that you can't represent with algebra tiles. So they are just a little bit of a learning tool to develop your skills, but again, they might not be the best method to use because you can't represent all expressions with algebra tiles, and some of them, like I said, can be very tricky if you got negatives involved. We're just going to concentrate on a few simple examples, and in this course, when you see a shaded tile, that represents a positive tile, and when you see a white tile, that represents a negative. So the first example, we're just going to represent expressions with algebra tiles. So the first expression is x squared plus 4x plus 3. And that would mean that you would need a large square that represents your x squared. Your 4 rectangular strips would represent your x's. And your 3 little unit squares would represent your units. And they would all be shaded because they're all positive terms. So if this expression can be factored, one of the ways that you check is if you can take those algebra tiles and arrange them in a rectangle, then you can factor the trinomial. So in this particular case, if we rearrange these tiles right here, we take these tiles right here that we've got drawn right here, and we rearrange them into a rectangle form, you can see right here in this rectangle, that's the arrangement of those tiles. It still has the x squared, has the 4x strips, and the 3 unit tiles. So when you look at the factored form of that expression, basically you would be looking at the outside dimensions of your algebra tiles. And when you're looking at the outside dimensions here, the side here you've got a long strip, so that represents x, and then a little short piece, so that represents 1. So x plus 1 would be your width here, and your length would be a long strip x, and then 3 short strips representing plus 3 because they're all positive, so x plus 3. So your dimensions, if you look on this side here, they're just written in here now, x plus 3 across the top and x plus 1 along the side, so they would represent the factors of x squared plus 4x plus 3. So we can check to see if those factors are correct by using the distributive property. And when you've got 2 binomials being multiplied, we can kind of summarize the distributive property as the FOIL method, because when you distribute the first terms in your binomials, that's F stands for the first terms, and then you distribute the x to the 3 out here, the second term in your second binomial, but basically it's the outside terms of both binomials, so that's why there's an O. And then you go, once you've done that, you distribute your x to both, then you distribute your 1 to both. And when you distribute your 1 to the first term, that's like the inside terms, hence the I. And then when you distribute the 1 to the second term, that's the last terms in both binomials, so hence the L. Or you can just use the arrows. I generally just use the arrows, but sometimes I'll refer to it as FOIL, so you'll know that it's basically just a distributive property for binomials. So when you check those products, x squared plus 3x plus x plus 3, you will simplify that to x squared plus 4x plus 3. So therefore, those 2 binomials are the factors of x squared plus 4x plus 3. So we're going to try the bottom ones here now using algebra tiles. So the first one has x squared plus 6x plus 5, and basically we would have one big square, 6 strips, and 5 units. And it's hard to do this unless you physically have the algebra tiles there. It's a little bit easier when you have the algebra tiles, but basically if you have to arrange those in a rectangle, you would have your square, big square to represent x squared, and that would be shaded. And then you would have, it needs 6 x's. So if I put, but there's only 5 units, so if I only put 5 alongside each other here, and then 1 along the bottom, and again these are all going to be shaded because they're all positive. And then, it's hard to see this, then you've got your 5 units along the bottom. So they would all be shaded too. So if you look at the outside dimensions, this here would be the long edge and a little short one, so that would be represented by x plus 1. And then if you look at the length, it would be a long piece, so that's x, and then 1, 2, 3, 4, 5, so it'd be x plus 5. So that would mean that x plus 1 times x plus 5 would represent the factors of x squared plus 6x plus 5 would be x plus 5 by x plus 1. And it doesn't matter which order you put those in. So if you want to check to see if that is correct, you could do your distributive property. X times x would give you x squared. X times 1 would give you x. 5 times x would give you 5x, and 5 times 1 would give you 5. So when you put those together, x squared plus x plus 5x plus 5, that simplifies to x squared plus 6x plus 5. So you would check, that's how you would check using the distributive property. The second one there, we've got basically an extra 2 strips and an extra 5 tiles. So if I look at the diagram I just drew, but just kind of extend it by putting 1, 2, 3, 4, 5, but instead of putting 1 down here, I'm going to put 2 down here now. And then basically what I'd have here is 2 rows of 5. And again, all these would be shaded because they're all positive terms. And if you look at the outside dimensions, this side here would be, you've got your long piece, which is x, and short, and they're all positive, so that would be x plus 2 along this side. And along this side, you would have your long piece, which is x, and then 1, 2, 3, 4, 5. So to be x plus 5 would be the other piece. Should have moved that down a little bit. So therefore, x squared plus 7x plus 10 would equal x plus 2 by x plus 5. And it doesn't matter if we put the x plus 5 first and the x plus 2 second, or vice versa. And the last one there, you've got 2x squareds. So we'll just try drawing my diagram a little bit smaller so I got a little bit more room. So that'd be 2x squareds. And I have 7x plus 3. So if I were to put, if I were to put 6 of them along here, so I'm just going to make that into 1, 2, 3. So 6 long strips there, and then 1 long strip right here. And then I'd have 3 units would be left to fill in this spot right here. That's not a very good picture, sorry about that. I wonder if I kind of fix that up a little bit there. Oh, I think I made it worse. Anyway, so you've got, if you shade all those in, makes it look even messier. That is, again, representing 2x squared plus 7x plus 3. So if I look at the outside dimensions, this is a long piece and 3 shorts. So that's x plus 3 along this side. And this would be 2 long pieces and 1, so it would be 2x plus 1 along this side. So therefore 2x squared plus 7x plus 3 would equal, in factored form, 2x plus 1 by x plus 3. And that's just a little lab, so that's, again, we won't be using algebra tiles a whole lot, and once you finish grade 10, you hardly ever see algebra tiles again. But for those people who are visual, this kind of might help you see where the factors are coming from. Okay, so we're going to move on to section 3.5. There's questions that you can try in there.